Hello! In the last video, we worked on the three first questions in problem 1 and we found the optimal solution to this LP using the corner points method. This time we're going to be using another method, which is the sliding method. To apply this method, we first have to represent two values of z. I'm going to represent z equal to 0 and z equal to 3. Of course, to represent any line, we need 2 points. To represent z equal to 0, we chose 2 points of coordinates 0, 0 and 1, 2. To represent z equal to 3, we are gonna use the 2 points of coordinates 0, 1 and minus 0.5, 0. So, what these two lines tell us is that as we go from the right-hand side to the left-hand side, z gets bigger. This means that the maximization side, the maximization direction is this way, and hence the minimization direction is this way. This is of course a minimization problem. So what we're gonna do is that we're going to draw some parallel lines, some other z lines, which are of course going to be parallel to this one. I went ahead and drew several other z lines until the one of these parallel lines intersected with the very last point, corner points in our feasible region before leaving the region, and that's how you locate your optimal solution. Now to the last question in our problem, which is this constraint binding? The binding constraint is one that is very crucial to forming the optimal solution. This means that if a binding constraint is removed, the optimal solution may not be feasible anymore. So the constraint in question here is constraint 2, 2x plus y less than or equal to 6, which is this constraint, C2. We can see that if this constraint is to be removed, we will no longer have this point B, which represents the optimal solution. So we can say that this constraint is binding. Mathematically, to verify whether any constraint is binding or non-binding, we need to check if the optimal solution is on that line, on the line representing that constraint. So the equation representing this constraint is 2x plus y equal to 6. The optimal solution is represented by B of coordinates 3, 0. The optimal solution is x equal to 3 and y equal to 0. So we try to see if we plug in the optimal solution here, if we would have the right-hand side equal to our left-hand side. So it's 2 multiplied by 3 plus y, which is 0. It is 6. So the right-hand side is equal to the left-hand side. This means that the optimal solutions falls somewhere on the line representing this constraint. So it is for sure binding. I hope this was clear, and let me know if there are any issues or anything unclear. And thank you for listening.